Hello, everyone. Welcome. Wow. Oh, thanks. I haven't even done anything yet. Wow. You're a good-looking group. Thank you for being here. My name is Daniel Roth. I'm a program manager on the ASP.NET team. I am actually here also with Damian Edwards. He's somewhere out around about. There he is. He's sitting it out, taking it easy right now, but he will be around afterwards to answer all of your questions. And in this session, we're going to be talking about full-stack web development with ASP.NET Core 3.0 and Blazor. .NET is a platform for building anything. You can build anything you want. You can build desktop apps. You can build mobile apps. You can build an artificial intelligence. You can build software that runs on the biggest servers and the smallest IoT devices. And I thought, let's build something. So in this talk, what we're going to do is we're going to build a web application. We're going to build a pizza store, a simple pizza store. It is a British pizza store. This is in honor of Steve Sanderson, who's a dev on the ASP.NET team. He lives in the UK, and he kindly helped me actually with a lot of the development of this app. But the idea of building this app, or at least going through pieces of it, is to see how with .NET Core, you can do full-stack web development from the front end all the way to the back end. That's what we're going to do. This is what it's going to look like. Let's sketch it out a little bit. We want to have a modern, interactive, rich-feeling app. So we're going to have some code that's going to run in the browser, and that's going to talk to our front-end server, which of course is going to be ASP.NET Core. This is an ASP.NET Core talk. And then as all those pizza orders come flooding in, as everyone realizes how delicious British pizza is, those are going to go in a queue. And then we'll have some worker processes that will handle those orders, process them, make the pizzas, get them out to delivery, and then some notifications will go back to our client, to the user, so they can know what the status of their pizza orders is. Now, this sort of opens up some interesting questions, though. Like, we want to do full-stack web development with .NET. So what should we use for these different pieces of this app? We want code to run in the browser. Can .NET help us there? We need these back-end worker services. What should we use to do that? We're going to use .NET, but what model? How can we make those services easy to configure, to do logging, and all those types of things? And what should we use for that notification pattern? What should we use for our server-to-server communication? We could use HTTP and JSON, but is there a more efficient way? Well, hopefully you heard earlier this week, .NET Core 3.0 Preview 5 shipped, and as advertised, it supports full-stack web development with C# and Razor. Now, what does that actually mean? Well, on your front-end server with ASP.NET Core, we have, of course, a long history of supporting a rich support for server-side rendering with MVC, with Razor pages. You can build APIs. You can build real-time services. We have great support for security and identity. And all that in .NET Core 3.0 just gets better. It gets faster. It gets stronger, easier to do diagnostics, all sorts of great stuff. On the client in the browser, we've got something new for you. We've got Blazor. Blazor is a new client web UI framework that runs directly in the browser via WebAssembly. We'll look at it more in just a second, but it's component-based. It's an event-driven, component-based UI model for doing client-side UI. Now, if you're still, well, first of all, the wonderful thing about that is that if you're a .NET developer, that means you can reuse your skills, you can share code between the client and the server. If you're still interested in doing JavaScript, though, that's fine. We've done a bunch of work also for our support for single-page application development using JavaScript with Angular and React as well, and we'll talk a little bit about that. On the back end, we have a new worker template for building worker services. These are long-running processes that run in your back end and handle things like batching, doing file batch processing, or handling various needs on the back end. And for your service-to-service communication, we've made a big investment in collaboration with the community to support gRPC. So this should help. OK, so that means with .NET Core 3.0, I think we can fill in some parts of this picture. For the front end, let's take a look at this Blazor thing. Let's try and do some .NET in the browser. For our back-end worker processes, let's use this new worker template. And for our notifications, we'll use gRPC to talk back to the front-end server. OK, to start out, let's start with the client, with the browser development. So what is Blazor? Well, like I said, Blazor's for client-side web UI development, .NET code that runs in the browser. You can build your client-side UI with .NET without having to write any JavaScript. And the way that works is that we've built a .NET runtime in a new open standard called WebAssembly that can just run in the browser any of your .NET assemblies. It's also a component-based UI framework. You build Blazor components using a combination of C# and Razor syntax. Razor is a nice marriage of HTML and C#. You can share your code with the client and server, use it on both sides of the wire. You don't have to duplicate. By the way, there's no code transpilation happening here. We're not taking your C# and trying to turn it into JavaScript or anything like that. There's no plugins. It is purely open web standards. If you want to leverage APIs that the browser exposes, you have full flexibility to do that. In fact, you can call into any JavaScript library that you want. Blazor's been a project that I've been working on for about a year and a half now. And for a good portion of that time, it's actually been an experimental project. It was something that started out as like a proof of concept. It really was a demo at a conference like this one. And we were like, could this thing be real? Could we do this? Would people actually want it? And I'm thrilled to announce that it was actually earlier this month, we announced that Blazor for WebAssembly is now in official preview. It will ship. It is no longer an experimental project, which is great. So it means it's something that you can look forward to using on the server. All right, let's take a look at Blazor. All right, so if you haven't used Blazor before, to get started, you're going to want to go to blazor.net. That's the magic URL. So this is the website where you can find all the getting started instructions. Just go through here. If you're on Windows, you can get started with Visual Studio. If you're on a Mac or Linux, you can get started with Visual Studio Code. We have tooling for Blazor now in Visual Studio Code. If you just prefer the CLI and your favorite text editor, that's fine. You can use the .NET CLI also to work with Blazor. Okay? And I've already done all those things. Let's create our first Blazor app. So I'm going to do File, New Project. By the way, notice that I'm using Visual Studio Preview. That's important. If you want to mess around with Blazor or .NET Core 3.0, make sure you're using the Visual Studio Preview channel. Visual Studio 2019 is not enough. There are new features in the latest previews that you need to do .NET Core 3.0 in Blazor development. So I've got the preview channel. It looks good. I'm going to create an ASP.NET Core web application. I don't know, should we call it Web App 1 was fine. Web App 1, click Create. And then, OK, so I've got the Blazor templates showing up right here. I'm going to pick this one, the Blazor ASP.NET Core hosted template. This is the full stack version where I have Blazor running in the browser, ASP.NET Core running on the server, and I can share code using .NET Standard. So let's create that. Great, and so we'll let the any packages that need to restore complete, and then we're just going to go ahead and run it and see what we get. And that looks good. Let's do it. OK, now, while we're waiting for the app to run, if you look in the Solution Explorer, you'll see that this app is actually made up of 3 different projects. Let me sort of collapse them so you can see them better. So there's a client project, a server project, and a shared class library. The client project, that's your Blazor app. That's the piece that's going to get compiled and then run in the browser on top of WebAssembly. The server project, that's a normal ASP.NET Core web application. And it has like an API controller that we can then call from our Blazor app. The third project is just a .NET standard class library, and it's referenced by both the Blazor client and the ASP.NET Core server. So you can share your code. The same model types can be used on both sides of the wire. Your validation logic can just be the same. No need to implement it twice, which is great. OK, let's look at what the app does when we run it. So we have 3 tabs here. There's a home page that just has some content. There's a counter page that we can click a button, and it updates the counter. Normally, that would require JavaScript to do, right? Because there's no page refresh happening here. The DOM's just getting updated. But I didn't write any JavaScript to make that happen. That's C# code that's running every single time I hit that button. As I click around, I can navigate forward and back in the browser. There's client-side routing happening here. On this FetchData page, this is a weather forecast table that issued an HTTP client request, like a real .NET HTTP client running in the browser, to the server, pulled down some JSON data, deserialized it, and then used Razor syntax to render this table. So that's what this is doing. Now, every time I show this, some people don't really believe me that this is actually .NET running in the browser. So just to prove it to you that, yes, this is .NET running in the browser, let me F12. And I'm going to go to the console, and you'll see the console's telling me there's some debugging hotkey I can press to do some Blazor-based debugging. So I'm going to do that. I'm going to Alt-Shift-D. That's going to pop up a little help page for me to get the browser set up correctly. I'm just going to copy this right here and then close the browser. And I'm going to restart it. I'm going to restart Edge with those parameters. And what that's going to do is start Edge in remote debugging mode so that I can connect remotely through it. And we'll set up a little debugging server between the DevTools and the browser so that we can augment the debugging protocol with .NET-specific concepts. So now if I do that gesture again, I should get the actual DevTools. There they are. Let's snap them side by side with the browser itself. OK, let's look at the sources of this app. And you notice that there are DLLs showing up in the browser. If I expand one of these, I see C# and Razor files showing up in the browser. Let me open up the Countr component. And let me see if I can make it a little bigger. Is this it? There we go. Is that better? OK, and then I'm going to set up, this is the increment count button method that gets called every single time I click the counter. If I set a breakpoint right there, let me click the button. We just hit C# code running in the browser on top of a WebAssembly-based .NET runtime using the browser debug tools. And we can step, we can look at stuff. So let's just go ahead and run through that. So this is really .NET running in the browser. Well, what does it involve to actually get that running? If we refresh again to see what was actually downloaded for this app, at the top, we can see there's CSS and JavaScript files. Here's a WASM file. That's the actual WebAssembly.NET runtime. It is mono in this case, but maybe you heard about the .NET 5 announcements, where all the .NETs are kind of getting like smooshed together, and all the good parts are kept, and all the bad parts being thrown away, and you end up with just one .NET. So this will be part of that .NET 5 wave. So it's OK that it's mono right now. It'll eventually just be part of .NET 5. And then below that, you see there's just DLLs. Like that's my app DLL, a normal .NET assembly downloaded into the browser and executed. Now, some people get a little nervous when they see DLLs in the browser, and they get asked about security. Like, wait, hold on a second. Like, is this safe? Is this safe, Dan? Yes, it's safe because WebAssembly code runs in the same security sandbox as JavaScript code. It can't randomly access the file system. It can't set up arbitrary network connections. It's running in that same secure browser sandbox. So it's as safe as running JavaScript code, for that matter. And you can do as much as JavaScript code could do. So yes, it is safe. It's not like punching out of the browser somehow to be able to do things that it shouldn't be able to. OK, that's Blazor, .NET running in the browser. Let's talk a little bit about components, though. So one of the things I love about Blazor is it's based on components. So each of these .razor files that are in my project, those are a Razor file, like they're written in Razor syntax, but they compile to a Razor component that represents a reusable piece of UI. So the Countr component, we saw the code in the browser before. It looks like this. We have a Razor directive at the top to say that this is a routable component. Requests to /Countr should end up here, is what that's saying. We've got some HTML markup. And then here we're using Razor syntax to say, please render the current count, which is the value of this C# field right here. And then we've got a button and an on-click handler. This is just a normal HTML on-click attribute. Normally you would have JavaScript here, but we're using Razor syntax to say, no, I don't want JavaScript. I would like a C# method to be called right here. So every time I click the button, that's what's being called. That's how you can implement components with Razor. The FetchData page is a little more involved, but not too bad. So we've got, again, that route. So this is a routable component to /FetchData. This is using dependency injection. You see that @inject? It's injecting an HTTP client, like a normal .NET HTTP client. It's already set up to talk to the right base address and all those things. It's populated into this property. Down below, when the component is initialized, it issues an HTTP request using that client back to the server, calls the API controller, which is in the server project. This is the actual web API controller in the ASP.NET Core project that's being called. And then it pulls down the JSON data, deserializes it in the browser into .NET objects, into this weather forecast array. And then up above, we use normal Razor syntax to render a table and render each weather forecast as a row in that table. It's just that easy. It's just C# intermingled with HTML. OK, so that's how you author components. To use them, you just use HTML-like syntax with the name of the component type. So if I wanted a Countr component on the home page of my app, I just say I'd like a Countr component right here using an HTML-like tag. If I rerun this app, I should now hopefully see a Countr component on the home page in addition to the Countr component on its own tab. Let's take a look at that, see that that's working. And on the home page, it loads, and yep, so there's another Countr component. So a reusable piece of UI, and the Countr on its own tab is still there, okay? So you can reuse components, so that's great. That's a component, that's part of the template, and you can, of course, write your own. But what's really awesome is that the Blazor community can take components, build them into, they just build to .NET classes, they compile into .NET assemblies, and then you can share them as NuGet packages. And there's a whole ecosystem already of existing Blazor components that you can just use in your Blazor apps. For example, if we look at this FetchData page, like it's rendering a table for the weather forecast data, which is fine. I mean, it's simple. But I want sorting. I want filtering. I want to be able to page through my data. I want a real grid right here. Well, fortunately, people in the community have already implemented grid components for Blazor. So let's just use one. I'm gonna switch this weather forecast table out with an actual grid component. To do that, I'm going to switch over to a new project that already has some of the setup done to save us some time. All right, so here we are, Blazor Grid app. It's the same app as before. Like, we still have the fetch data with the table. But the things that are different, I've already added a NuGet package. In this case, I'm using the Telluric Blazor UI components. This is the Telluric Grid. I believe they announced this week that they've shipped their components now, which is awesome. And then there's a little bit of wire up, like in startup, just to add the Telluric Blazor-related services. OK, so let's go into fetch data and see if we can use this grid. What do we do? I'm just going to delete all of this table, and let's see if we can use the Telluric Grid. I think it's Telluric Grid. Yep, I get completions. Let's just complete the element, and then I need to pass it some data. Awesome, and I want to pass it the forecasts. Great, get completions. And then let's turn on all the features. I want it to be pageable. I want it to be sortable. Yes. I want it to be pageable, sortable, filterable, yes, and so forth. And then in here, you would define all of your Telluric Grid columns, I think is what it is called, Telluric Grid columns, yes, and so forth. And you would define each column. I'm going to spare you me typing through all that and making typos. I've got it already typed up here. This is what the final version of that grid looks like, with all the columns already defined. If we then save and rerun the app, by just adding a NuGet package, following a little sample code. Loads, and let's go to fetch data. Boom, OK, so now we've got like a grid thing here. Like, can I sort? Like, if I click on stuff, it sorts. If I want to, filter by freezing over here, yeah, I could do that. So, it's got paging down at the bottom, I think. Yep, there's paging support. So a full component you can just reuse. And there's a whole ecosystem of people that have built components like this that you can just pick from. So that's really nice. Another really nice thing is that you can just reuse existing .NET standard libraries. It doesn't have to be a component library. You can just use the ecosystem of .NET code that's already been written. For example, a scenario we often talk about here is, imagine that your boss comes to you and sees this lovely table and says, that's great, but I would like to get that data downloaded so I can open it in Excel. And you think to yourself, OK, I could probably string concatenate a comma separated values file for you and make that happen in the browser. And your boss says, no, it has to be colors. It has to have conditional formatting. It has to have charts. It has to be a full Excel spreadsheet. And you're like, oh, OK, well, I don't know about you. I don't know how to code up a full Excel spreadsheet. But hopefully, someone in the .NET ecosystem has already done that for us, and we can just use their existing code. Let's go see. So I'm going to add a dependency to my Blazor Grid app. Let's go look on NuGet and see if we can find somebody who has saved our job. So let's see, Excel. What do we got? So there's some interop library, some Excel reader thing. No. OK, EP+. Create advanced Excel spreadsheets using .NET. That sounds promising. It's got 7.5 million downloads. Let's just download and install that. Maybe this thing can help us out. And let the internet do its thing. So the key thing here is any .NET standard library can work in Blazor within the constraints of the browser sandbox. Like if you're trying to use a a library that like does native interop, like that's not going to work in the browser. If it tries to access the Windows registry, you can't access the Windows registry. Those things will just throw platform not supported exceptions. But otherwise, you pretty much can use any .NET IL that is .NET Standard 2.0 compliant. OK, so we got our library added. Looks like it's showing up in the dependencies node. All right, let's add a button now to fetch data. Let's add a button right here, download. And I've already added a download file event handler down here. We just have to wire it up. So on-click equals download file. Yeah, there it is, showing up in IntelliSense. Lovely. OK, so when that button gets clicked, it should call this method. And now I just need to do some code with that library. I happen to know that it needs some namespaces. I think these are the ones that it'll need so that we can IntelliSense our way to victory. And if we go down here, I think it's like Excel, like package, and so forth. Like there's a you can read the docs and IntelliSense your way to victory. The code eventually looks something like this. I'm just going to copy and paste it in. It's a little long, I know, but it's actually pretty trivial stuff. Like there's nothing real complicated here. You create an Excel package. I'll walk you through it real fast. You then add a worksheet for your forecasts. Then here we're using, C# link expressions to pull in all the weather forecast data into that forecast sheet. And then we're adding conditional formatting so that if the hot temperatures are red and cold temperatures are blue, we compute Fahrenheit for people that don't know how to read Celsius, and then we do something to make it look pretty. Like that's all it really is. And then we download it. So I think that's all we need to do. Grab a library, use the ecosystem. And hopefully by lunchtime, you go back to your boss and you say, OK, I tried out this Blazor thing. I think this might work. Can you give it a try for me? So download. Looks like it downloaded something. OK. Looks like it's opening Excel. Looks like we're making progress here. And then it's downloading from the internet. Oh, yeah. OK, yeah. Is this really got like conditional formatting and stuff? So if I type 30 degrees Celsius in here, that's super hot. So that's a full Excel spreadsheet that we just generated from the browser using just a random .NET library that we found on NuGet. So that's pretty cool. All right. So that's what Blazor is. Oh, thanks. OK. But we wanted to build pizza store app, right? We want to build blazing pizzas. So I have started this app already. We're not going to build it completely from scratch, of course. In fact, I've done quite a bit already. But so this is the app. Let me just run it so you can see what UI I've already got in the application, and we'll add some stuff that's missing. So this is the pizza store app. There it goes. OK, good. And I think we can close all these other tabs now. All right, OK, so this is Blazing Pizza. It's got a couple tabs, right? It's got some auth UI wired up, and it's got this sort of right-hand pane for managing your orders. So sort of a scaffold of the UI. So what I want to do with you guys is let's add the pizzas, right? Let's make this white space actually have all the pizza specials that you can select and then configure your pizza with what toppings you want and so forth. OK, so where is that? So if we open up Blazing Pizza, this is the actual Blazor app. The things that are Blazor related here, this is the app. This is a Blazor component library. That's some components the devs helped me out with. There's a shared class library here at the bottom that's just a .NET Standard class library that has all my model types. Like here's where I put my DB context for EF Core for talking to the database. Here's my model for the pizza and so forth. All right. So let's look at the UI, though. We want to add some UI. It looks like it was on the home page, so I'm going to open index.razor. It looks like there's a div here at the top that's main. That looks promising. Then there's this sidebar div. That's probably that little gray section on the side. And then there's a custom Blazor component here for a dialog box for configuring the pizza. And that part's already been implemented for us. Down at the bottom, when the component is initialized, it goes and gets the pizza specials data from the database. OK? So this is the part we want to implement. It looks like the list of pizzas is in this list field right here, specials. So let's see if we can do it. So let's create an unordered list. And I think the class that was set up for this is pizza cards. Pizza cards. Yeah, and get some IntelliSense for that. Nice. OK, we want to check if the specials is not null. Like we don't want to, if we haven't got the specials yet, then we don't want to render this stuff. Then we're going to do for each. for each special in specials. Great. Lovely IntelliSense. And then here's where we would then render like a list item for each pizza, right? And put some fancy, an image and some styles and so forth. Now I've gone ahead and implemented a little reusable component for each of the pizza specials that we want to render. It's over here in the shared folder. So let's look at pizza special card. This is just a reusable component, a .razor file. There's the list item, right? It has an on-click handler that's wired up that it's actually passing through. Like below you can see there are two properties that are parameters for this component. These are things that you can specify as attributes when using the component. I can specify which pizza do I want to render here, and what do I want to happen when that pizza is clicked. The rest of it is just sort of like bootstrap styling and CSS stuff. Okay, so that's what we want to use. We want to use the pizza special card component in our main UI. So let's go back. So for each special, let's do a pizza special card. Shows up right there. Great. And the pizza special we want to do is the current one in the for loop. Perfect. IntelliSense. Love it. And then on click. Now this part's a little bit more involved. When we click the pizza special, we're using this order state service up above to coordinate the UI for creating orders and managing the configuration of the pizzas. So what we're going to do is we're going to call an API on this service that lets us show the configure pizza dialog. Okay, so let's do that. So let me finish off this element, and then let's do. We're just going to put a little lambda right here, and we're going to take the order state. And we're going to do what? Show configure pizza dialog. Sounds like the method I want. All right, show configure pizza dialog. And then this guy is going to take the current special pizza, because we want to configure that pizza that's there. All right, was that enough? Let's see if that updated our UI. Okay, yeah, we got some pizzas. We have a baconatorizer. We have the Brit. Let's do the Brit, and we can put some freshly baked scones on our pizza. That sounds delicious. And we can put some duck sausage, and we'll order that. Okay, so you can see some basic UI, and that's all done with Blazor. All right, cool. Check step one complete. Let's move on. By the way, if you do want to build that entire UI, you can, because we have a public Blazor workshop that walks you step by step building everything that's in that UI. It's at aka.ms/Blazor workshop, and it's a lot of fun. You should definitely try it out. aka.ms Blazor workshop. Also, if you want to try out some of the many components that are available from our many partners, there's suites of components that are available from Telluric, from DevExpress, from SyncFusion, with grids and tab panes and all these things that you can use today with your Blazor applications. Now, mostly we've been talking about Blazor on the client, where Blazor runs directly in the browser on WebAssembly. But there is an alternative hosting model that we are also supporting, which we call Serverside Blazor. Serverside Blazor is a little different. It uses the same components. You don't write the components any differently. In fact, you can flip the app back and forth between a client-side and server-side hosting model. But the components run on your server instead of on the client. And the UI interactions are all handled over a SignalR connection. So when you click that button on the counter, that sends a UI event along the SignalR connection to the server. The counter component actually runs server-side. The Blazor runtime looks at what was rendered by that component and calculates a DOM diff and serializes that DOM diff back to the browser over the SignalR connection, and then the runtime handles applying it to the UI. So that's the server-side Blazor model, and it has a number of benefits. Like one benefit is it has no dependency on WebAssembly. The WebAssembly.NET runtime is the thing that needs the most work right now. So we can actually ship server-side Blazor faster. The app starts up faster because you don't have to download a .NET WebAssembly runtime along with your application. That's kind of nice. It also has some architectural simplicity to it. Like from your components, if you want to just talk to the database. Well, the component's running on the server. You can do that. You don't have to go through the chore of setting up an API and doing the HTTP call to the API and then have that talk to the database, because you're already running on the server in this model. Of course, it has some downsides as well. It's a connected model, so all of your clients have to actually have a live network connection to the server. No offline support with server-side Blazor, whereas with client-side Blazor, you absolutely can do offline. Also, you're paying with your server resources for scale out. Like all the UI is running on your servers now instead of running in the browser on the client's machine. So you have to pay for that. But a lot of customers have told us that this is a compelling model. They like the idea that their code stays on the server and it doesn't leak into the browsers to the clients. And so this is something that we're actually shipping in .NET Core 3.0. Server-side Blazor is in the box. And that includes not only the hosting model, but the entire component model. Everything that we've done with components is already in .NET Core 3.0. The only thing that is not going to ship with .NET Core 3.0 is the run on WebAssembly support. That will take a little longer. That's part of the .NET 5 wave of efforts. It will happen sometime after .NET Core 3.0 ships. But it is in official preview, and it will ship. We will have roadmap details for you as soon as possible. But just to give you an idea of what server-side Blazor looks like, let me do a quick demo of that. So let's now go back to Visual Studio and do another file new project. And I'm going to create another ASP.NET Core web app. And web app 2. OK, and this time I'm going to pick the Blazor server-side template. OK? Now, a lot looks the same in this application. In fact, when I run it, it will look pretty much the same. We'll have a Countr component. We have a FetchData component. But there are a couple key differences. So I can click on the Countr. It still has that rich, interactive client feel. So there I just rendered the weather forecast pane. Things that are different, when I refresh, it's almost instantaneous. Like, it's really fast. And that's because, well, when we download this app, let's see, let's Control F5, this app, the network tab. This app is only about, just under 400 kilobytes. I don't know if I showed you, the client-side Blazor app by default is about 2.4 megabytes compressed. We hope to make that smaller, like we're working on slimming down the runtime. But it's got a little beef to bring a .NET runtime down with you. Whereas the server-side Blazor app, you don't have to do that. All you need is to be able to set up the WebSocket connection. And that's what we're seeing here. This bottom request is setting up a WebSocket connection with the server. And if we clear all the binary messages that were sent, and then we start clicking the counter, you can see that traffic starts to flow. So every time I click the button, it sends the UI event to the server, does a re-render, and then the UI diff comes back to the client and gets applied. That's how this application works. So it has some benefits. This will be available in .NET Core 3.0. You can go with it into production as soon as .NET Core 3.0 ships and is ready for production. Client-side Blazor on WebAssembly will ship sometime later. Now, a lot of people ask me, OK, this is cool, but what about MVC? What about Razor Pages? How do these two things relate? Well, the answer is they can get used together. You can use components with pages and views. So MVC and Razor Pages, those are a request-reply rendering model. You send a request to the server, it renders some HTML, and that gets sent back on the response. MVC and Razor Pages have the full context of the request. But you can add a component to your page or view. That component can have state. It's client-side stateful UI. When a request comes in, the HTTP context gets established. The client-side UI, the components don't see that HTTP context. Like you can almost think of them as like a component in a WPF or WinForms application. They don't know about requests. They just have what state the UI is in. But you can execute the component's rendering logic as part of the rendering of the page or view. The page or view can even pass data into the component to tell it what it wants to render. And then when the response goes out, the whole thing gets sent, the result of the component rendering, along with the rest of the page or view. Then the WebSocket connection, the SignalR connection, can be established back to the server, and that component can then become interactive. So you can imagine adding little interactive widgets to your pages and views. Let me show you what I mean and how that works. I'm going to go back to the server-side Blazor app, and let's look at the code. Notice that under the pages directory, that's not the right one. this is the right one. Under the pages directory, we still have Countr, FetchData, and the home page. And the code is literally character for character the same. The one thing that's different, though, is that we have this host CSHTML file. That is a normal Razor page. That is the page that is hosting the Blazor app and rendering it on first request. If we look at its content, it has a bunch of stuff in the head for setting up scripts. And then in the body, there is this one call to an HTML helper to say, please render this component, the app component, the root component of this app right here. That's how that works. But you can render other components if you want to. If I have a Razor page and I want to, say, render a counter, like right here, we can do that. So await HTML.render component async of counter. And if I wanted to pass data into that counter, I could right there. Now when we run this app, what I would expect to see is a counter component rendered at the top, and then a whole app rendered right beneath it. Let's see if that worked. And there you go. So now we've got a counter at the top, and we've got the normal counter that's part of the application. Both work just fine. So you can put components interleaved with your pages and views. All right, so we've talked a lot about Blazor. A little bit about the JavaScript support that we have in ASP.NET Core as well. We have been doing a bunch of improvements there. We have upgraded our Angular templates to Angular 7. We will probably also update to Angular 8 before we ship 3.0, because I think Angular 8's due out this month or something like that. We've also updated the React templates to React 16, and we've added authentication support to the JavaScript SPA templates. The authentication support is based on IdentityServer. We give you built-in UI for login and logout. You can easily protect your APIs and also the specific parts of your client-side app. You can add like route guards to different parts of your app to say you have to be authorized in order to access this part of the app. And again, it's based on a great community project, IdentityServer. If you haven't used them, they're a really nice component. I'll show you a quick demo of that just so you can see what it's like. If we go into Visual Studio and you want to create a new, say, Angular app with authentication, it's as easy as doing File, New Project. Say that you want to create an ASP.NET Core web app. Let's do Angular auth demo. Sounds good. Create. OK, and then let's see, down here at the bottom, I think, yeah, there's Angular. And then you can go into this authentication section and say change. And then here you can switch it from no authentication to individual user counts. And that will enable authentication in that template. And I could do that, but then I'd have to wait for the NPM restore to complete, and life is too short to wait for NPM to restore. So I'm going to go ahead and open up an existing Angular app that I've already done the NPM install on, and we'll just run it real quick so you can see that auth is set up there. There's really 3 parts to the auth that's set up. There's the UI. If you look under the client app section where all the JavaScript code actually lives, and I think it's under app and app.module.ts. So here's where it's all being set up. We give you this where is it? API authorization module. And then we give you a notion of an authorized guard that you can use to protect client-side routes. We'll also set you up with a provider that will put the acquired security tokens on all the HTTP requests that are going out back to the server. On the server side, we wire up the app to have the database gets set up. We wire up the default identity UI for handling logins and logouts and all that stuff. We set up IdentityServer for you, and then set up JWT token-based authentication for all of your APIs. So that's how that all works. And did I run it? Oh, I didn't run it yet. Let's make sure we run it. It takes a second for the Angular dev server to wake up. I don't know why. I suspect there may, like, the amount of preview bits I have on my machine right now, I find very impressive. Like, I have a preview.NET Core SDK, preview Visual Studio, preview Edge, preview Blazor bits. So some things that may have a few bugs. I suspect the fact that this first request takes so long is actually a bug, or it's just some weirdness with the Angular dev server that we use under the covers. Let's see if it's going to render. There it comes. OK, great. So if this fetch data route is the protected route. That's the one that had the authorized guard. If I click on it, I get bounced over to the login page. There it is. And I can log in with my very secure password. And then, yeah. And then I should now be able to see the FetchData equivalent in Angular. So that's authentication already set up for you in the SPA templates. OK, we've talked about the front end, I think enough now. Let's go to the back end now. What about those worker services? Like, how are we going to get the orders, the pizza orders off of the queue and do something with them? Like, what's the model that we should use for doing that? Do we use ASP.NET Core? Do we just write a console app? What do we do? Well, we have this new worker template, a worker service template in .NET Core 3. And it's a template that's intended for long-running worker processes. They may have endpoints, or they may not. Like, they might just be something that's doing some work based on some other input. You can easily host them as Windows services, using systemd, using web jobs, in containers. And the thing that's really nice about them is they integrate with the same abstractions that we use across .NET Core for config, for logging, and for DI. Let me show you what I mean. OK, so we're going to create a worker. Let's go back to Visual Studio. Let's do File, New Project. And let's create another ASP.NET Core app. This one's going to be called Worker Service 1. Let's create that. OK, and then up here at the top, Worker Service. Let's take a look at what this template will give us. OK, it's a pretty simple template, like pretty bare bones. It has a program CS, so it's like a console app. And this kind of reminds me of the code that you would see in like an ASP.NET Core app, where we set up the ASP.NET Core host and Kestrel as the server and all that stuff. Except this is not a web host. This is just a generic host for hosting some background service. But you see that I get to use similar abstractions. Like I get dependency injection. Here I'm configuring services using service collection, just like you would in ASP.NET Core. If we look at the actual worker type that we're setting up, it has iLogger, so the same logging abstractions, and you get config as well. Like you can use the same config abstractions. So that's kind of nice. If I run this guy, you can see all the worker really has is just a single method that's like execute, and it just runs. The host provides start and stop, but it also provides nice integrations with specific hosting models. Let me show you what I mean. So if I run this will just run as a console app, and it will just it's running in a loop, I think, and it's just spewing out the current time over and over and over again, right? OK, that's pretty simple. But let's say I wanted to run this as like a Windows service. Well, we can do that. Let me pop over. To do a Windows service, I'm going to need an admin command prompt, and you probably would like it to be a little bit bigger, I'm guessing. There we go. OK, so let me go to, what was that, Worker Service 1? No. CD, Worker Service 1. All right, and what do we want to do here? Oh, so first of all, I'm going to add one package to this application. It's a package available on NuGet, and it is Microsoft extension. Yeah, I got it right here. Hosting Windows services. This package will wire up Windows service integration for the worker template. So I'm just going to add that into the app. Accept. OK, that looks like that completed. Let's see if the package is actually there. It looks like it is. OK, now to wire it up in the program CS file where I'm setting up the host, I just need to add one line of code. I think it's use Windows service. And that will set up the right content route. It'll also set up the output from the service to go to the event log, so you can get some diagnostics help, those types of things. All right, now let me go back to my admin prompt. Let's .NET build to make sure this is working. I had this problem before where for some reason it keeps removing the NuGet package. Why does it keep doing that? So let me get this back. See, no, it's there. See, it's there. It says it there. Save. Don't go away again. Restore. Good. .NET build. And what I want to do is I want to publish this app. If I can get it to build there. OK. .NET publish, and I'm going to put it just on my C drive someplace. Worker Service 1. Is that a good place? All right, great. And then I'm going to use the, what is it? The service SSC, service command tool. I forget what this tool is called. Service something tool. Service control manager tool to create a Windows service for my app. So sc create, and then I need to give it a name. Let's call it worker 1, sure. And then you got to give it a bin path. So the bin path should point to the executable that was just created from that worker service. So the bin path should be where I published it, worker service 1, and then worker service 1.exe. So let's create a Windows service. Success, I see at the bottom. That's promising. And then let's start it. So start worker 1. OK. Start pending. So hopefully that's now running. Now, how can we tell that it's actually doing something? Well, like I said, we wire it up to the event logs. So if I go to my event logs and I just refresh here, you see worker service 1 is now spewing stuff into my application event log. So it's just that easy to get a .NET Core app now running as a Windows service. All right, so that's a worker. And I'm going to use this in my app. Let me stop it first. Oh, cool. Someone like that. That's awesome. What is it? Stop worker 1. Yep. Stop pending and then delete worker 1. Cool. OK. Now, I want to use some workers in my Blazing Pizza app to handle orders coming in on the queue. So when we click, let's go to our index page. Down at the bottom here someplace, there should be a button. Yeah, this button right here. When this button is clicked, on click, it calls this place order method. And that place order method then over here, right here, yeah, place order. It calls into my into my pizza store service to place the order. Let's see what that pizza store service does. So pizza store down at the bottom. Here it's taking the order and it's going to stick it on an Azure queue. I'm using the local queue storage emulator on my machine to have a simple queue set up that I can demo with. So it's just going to take the order and stick it on the queue. And then I want a worker that's going to be listening on that queue to pop off those orders and do something useful with them, like make me a pizza. OK, so down here at the bottom, we have a worker, pizza worker project that I created using the same worker template that you just saw. Looks the same, right? It's got the similar setup. I've configured a few services, like it's going to talk to the database. So it'll handle putting the orders into the database for me. And then it sets up a background service. So in here, we're doing a few more things than we saw before. Like I'm setting up the actual queues that I'm going to be listening on. I'm actually going to listen on the pizza order queue. And then when the pizza is ready to be delivered, I'm going to put it on the pizza delivery queue for a different worker to pick up. All right? And then we're injecting the normal services that you would expect to use in a .NET Core app, logging, DI, and configuration. Down below, we start up the service and basically set up the connections to the queues. That's what we're seeing here. So this pizza orders queue is getting set up and the pizza delivery queue. And then down below in the execute async method, we're in a loop, and we're just basically polling the queue for new messages. When we get one, we deserialize it, and then we save it to the database. This is what's happening down here. Now, down below, we start getting into the notification patterns and so forth. We're going to ignore that for now. We'll get to that in just a second. But this should be popping stuff off the queue. Let's see if that works. There's another worker, by the way, that handles the delivery queue, and it's basically the same code. It's just that this one also mimics a driver, like driving from point A to point B and sending notifications about where the driver is at. OK, so let's get both workers and the app up and running now. So I'm going to set my startup projects to be multiple. Good. And let's just run everything. We're going to run the Blazor app. We're going to run these 2 worker processes. And I believe I have the storage emulator running in my system tray. Yes, down there. So that's it, that little Windows icon. OK, so this is a pizza worker that just started up. It's waiting for some orders. And then I have my pizza delivery worker that just started up as well. Now, where's my Blazor app? Is this one it? OK, so let's add, I don't know, the Baconator, whatever, pizza. And then let's click order. It's going to ask me to sign in, which is fine. This app's wired up to use Microsoft account-based logins. There it goes. And hopefully, OK, so you can see the pizza worker is now kicking in. It's like preparing order 19. And it's moving along. OK, so there it saw the message on the queue. It popped it off. And now it's preparing that order. And it'll put it onto the delivery queue. Let's see. Sent for delivery. So let's check the other guy. OK. Just got the order 19 out for delivery, and now it's simulating the movement of a driver from point A to point B by sending out a stream of status notifications. Does that make sense? OK, so that's using workers to handle the queues. So I'm just going to stop these guys And we'll see a little bit more of the app in just a second. OK, what about the order status? How do we do that? Well, new in .NET Core 3.0, we now have great support for gRPC. This was actually a collaboration with the community. If you're not familiar with gRPC, it is a high-performance, contract-based RPC protocol. It's got really great broad interoperability with a whole bunch of different frameworks and stacks. Like there's a gRPC implementation for pretty much any language or framework that you want to use. And it's really great for service-to-service communication because it uses a tight binary format that's very efficient. So for our workers talking back to the front-end server to tell it, like, this is your order's been prepared or your order's been delivered, let's try and use gRPC. How much time we got? 10 minutes. OK, we can do it. Whoa, that's too far ahead. Back. All right. So back to the demo app. Let's look at gRPC really quick. So to create a gRPC service, it's pretty easy. You just do File, New Project. Again, ASP.NET Core Web App. And then we're going to do a gRPC service one. OK. And then down here at the bottom, I think is, yeah, gRPC service. And let's create that. So gRPC is a contract-based model, and the contract is defined using a protobuf file, which is just an independent format for representing the RPC actions on your service and the structure of the messages that that action uses. So here's the protobuf file for this, hello world gRPC service. We have two messages, hello request and hello reply that both just have a string and a name. And then here's the actual service definition. It defines an RPC action called say hello. And that sends a hello request that receives a hello request and returns a hello reply. Now, the tooling and the infrastructure that's added to this app, and there's a couple of packages here. There's the actual protobuf implementation, and then a couple of packages from the community, gRPC.tools, and then one that we've been working on, the ASP.NET Core gRPC integration. What this will do is it will see that protobuf file and then turn it into code for you as part of the build. So down below, there is a service implementation. This part of the code wasn't generated, but if I F12 on this greeter base, that's all auto-generated code based on the protobuf file. Okay? And then you can take that same protobuf file and generate a client and then talk to this service. It's pretty simple. I'm probably going to skip doing that on the fly right now just so in the sake of time. But so what I want to do with Blazing Pizzas is I want to have a gRPC service in my app that receives status notifications from clients. So let's look at Blazing Pizzas real quick. OK, so in my Blazor app, I have a gRPC service. There it is. In fact, and there's a protobuf file right here. So this just defines a single RPC action that has it takes a status update and then just returns an ACK. It says, yep, I gotcha. And here's the status update, which is just all the data about the current order. And so we've got the service all set up in the app. And then down below, I created a little helper class library, this order status client, that has the protobuf file again. And it generates client-side code. If you look at the MS build file, where's the protobuf? It's down here. So here it says in the MS build project file, it says, this is my protobuf file, and I'd like to generate client-side code for this guy. Don't bother with the server-side code here. And so this library now has a reusable gRPC client, and it's referenced by both of the workers. So if we go back to the pizza worker, we can look at the rest of the code now. So after the pizza worker has saved the order to the database, it then it opens up a channel and a pizza order status client, that's the generated gRPC client, to tell the front-end server again that, hey, I'm now preparing your order. And then it just waits 10 seconds. And after it's done that, it puts a message into the queue to say, OK, I'm handing the pizza off now to the guy with the car to go deliver it. In the pizza delivery worker class, a little bit more stuff going on. But after it gets a pizza delivery message, an order that it should deliver. It saves that to the database. And then it starts a loop where it calculates all the points between your current location and some place that mimics where the pizza store is, and starts sending updates and saying, OK, the pizza is now at this location. The pizza is now at this location. And when it finally arrives at the final location, it says, OK, it's delivered. And that's all done over gRPC. So let's see if we can get that all working. So I'm going to rerun the app. Do I still have any of the processes running? Let's get them all shut down so that we don't have any conflicts. And let's rerun it. Cool. Let's close all the other browser tabs. OK, so we've got that's pizza worker, that's pizza delivery worker. All right, so now let's add another pizza. That looks good. Let's order it. We're going to log in. And we should see that's the pizza delivery worker. Here's the pizza worker. Should pick that up. All right, it did. It's preparing order 20. I should see that on my order status list. I think it's this one. Yep, that's order 20. I can now click on the details. And if I just watch this, so currently the pizza's being prepared. And it should be prepared. You know, pizzas take about 10 seconds to cook, right? You know, about-ish. You know. Oh, so now the pizza's done. It got handed off to the delivery guy. Now the delivery guy is like, you know, sending his GPS coordinates. Now you might wonder, how is it possible that the driver can like plow through different blocks in Seattle? Drone delivery, of course. This is a drone-delivered pizza, and it comes right to us here in the center. And if I had a guy with a pizza show up in the door, that would have been awesome, but, you know, sorry. So that's how that's all working. So we had a queue with workers that are then sending gRPC notices back to the front end, and it's all being rendered with Blazor. So there, we built a full-stack app. Woo! But there's more. OK, so a couple other things that are still cool in .NET Core 3.0 that you have to know about. Diagnostics is getting so much better. We now have cross-platform tools for looking at event counters. If you're familiar with perf counters in Windows, event counters are sort of like the cross-platform version of that implemented in .NET Core. The .NET Counters tool will give you an ad hoc way of monitoring how healthy your app is, and you can see that from the console. .NET Trace is a way to collect trace files in a cross-platform way that you can then view in perf view or in Visual Studio or in third-party apps like SpeedScope. That's pretty cool. You can also collect .NET dumps using .NET dump on cross-platform, and you can even do analysis of those dumps as well. The .NET dump tool includes a REPL for doing SOS-style debugging with your memory dumps, so you don't have to go, you know, messing around with WinDBG. So that's pretty nice as well. Maybe some of you have hit this problem with my app not starting. You know, if anyone using .NET Core and ever had like 502 gateway error, like your app didn't, yeah, I see a few hands, OK. So we've been doing a lot of work to try and make that error a lot easier to diagnose. In 3.0, you will get a developer exception page right in the browser when that stuff happens, and you'll see the exception stack trace. In the event viewer, you will see the full exception stack trace as well. We're also working on a full Azure portal experience, so you can see all of those errors directly in the portal as they get spewed into the event log. So a full experience for diagnosing startup failures is also coming. Last thing I really wanted to show you is performance. This is amazing. Like, .NET Core 2.2 is already fast. Like, if you look at the Tech Empower benchmarks, which is a public open source benchmarks that compares all the server stacks on the planet, 2.2 is like top 5, top 10 on all those benchmarks. And the only other guys that are up there that beat us are like things you would never want to use. Like, C++ or C or something like that. We're the only real web framework really at the top there. We're really fast. But 3.0, oh my goodness. So with the plain text benchmark, 39% throughput improvement, 45% time to first request improvement, 92% working set memory improvement over 2.2. And this just continues for even the more real-world benchmark scenarios, like working with JSON files. Again, huge improvements. The Fortunes benchmark is where you have like a database and APIs and stuff. Huge improvements. Where do these come from? We reduced allocations across the board. Like the plain text benchmark is now completely non-allocating. Tiered compilation made the startup much faster. We have a new endpoint routing system in ASP.NET Core that's very performant, very efficient. And we also fixed a lot of the GC memory reservation defaults so that the working set is much more efficient as well. So that's pretty cool. And we're just getting started. Like we haven't even finished shipping yet. This is just going to get better. This is all the stuff that's available in ASP.NET Core 3.0 that's coming. Some of it's already shipped in previews. Other stuff is still coming, like the certificate and Kerberos authentication. That's going to be coming. I'll let you guys check this slide out afterwards. I know a bunch of you are trying to take pictures of it. But I want to tell you about the schedule. We're basically going to ship a preview every month. So we just shipped Preview 5, Preview 6 in June. There will be a go-live release in July. So if you want to go live with, say, Blazor, server-side Blazor, the first time you'll be able to do that with a go-live release will be this summer, which is pretty amazing. The GA release for .NET Core 3.0 will ship in September. Try out the bits. Let us know what you think. You're all great for sticking it out here and listening to me. Thank you so much for using .NET, and I'm happy to stick around and answering of your questions.